Good. Now we're going to do an application of drawing of the graphs. Now I have a problem here on the board, and our problem reads thus. It says Temba throws a ball vertically upward with an initial velocity of 24.5 meters per second. It takes 5 seconds for the ball to return to Temba's hand. The question is, sketch 3 types of graphs explaining the motion. So I'm going to start with the easiest one, position versus time graph. Going to start with position versus time graph. It is very important for me to position versus time graph. If I'm marking, you must indicate the maximum. You must indicate the maximum position. Do you guys understand? But for that, I'm not giving the maximum position. It means I have to calculate the maximum position. You go back at the back of your formula sheet. You are going to use this. It's easier to use this. Vf squared is equals to Vi squared plus 2. In this case, it's vertical projectile motion, 2g delta y. At the back of your formula sheet is given as delta x. But for a vertical projectile motion, you just change delta x to delta y. That's not a problem. So all of us here, we have a task of finding delta y. Right? And as I calculate, you guys are going to input the values and are going to tell me the final answer. So I know that velocity at the final, velocity at the maximum point is 0. Right? And remember, I'm projecting, I have an initial velocity. Right? My final velocity as I go up will be 0. Right? Therefore, my Vf here will be 0. So I'm going to have 0 squared is equals, what's the initial velocity of Temba? I'm taking upward as positive. Upward is positive, meaning everything that goes up is positive. Good. Now here, Temba, the initial velocity that the ball is being thrown up is 24.5 squared plus 2. My g, I said upward is positive. Upward is positive. Right? But remember, gravity pulls everything towards the center of the earth. So gravity will be negative if my upward is positive. So I'm going to have negative 9.8. Do you guys understand? Make sure that you understand. I'm saying upward is positive. Initial velocity. Temba is projecting the ball upward. Now, if upward is positive, everything that goes up is positive. So that's why I have a positive value there. Now, because gravity pulls everything towards the center of the earth, right? Remember, its acceleration will also be negative because it pulls. Good. Now I have delta y there, right? It's easy to see that I'm going to have this negative 24.5 squared. I'm just moving it to the other side. Now I'm having, this will be negative, I trust you, negative 2 times 9.8. Negative 19.6 delta y. Here we are going to have 24.5 squared is 24.5 squared. Oh. 24.5 squared. 600. Negative 600.25. Negative 19.6 delta y. So I'm going to have negative 19.6. Negative 19.6. So I have delta y there. What's my value? It makes sense because my axis, you see, I'm going to get a positive value. It makes sense. Position is positive. 30.625 meters. Now I have my maximum point. Now I can go and sketch my position versus time graph. Please note, good position, please make this note. Good position versus time graph. When the marker is marking there, she or he is looking for the maximum. You must state the maximum distance above the ground. It's very important. You must also indicate time at the maximum point, and you must also indicate time for the entire motion of the ball. So they're looking for three things.
Sorry, sir.
Yes.
Is our final answer going to be negative or positive?
It's going to be positive.
Okay.
It's going to be positive, reviewer. Good question. Now, it's negative divided by negative is positive. So it's going to be 30,625 meters. Very brilliant review. Now, let's move forward. When the marker is marking the paper there, I said she or is looking for three things. One, you must indicate the maximum position above the ground. That's why we have started with this calculation. Two, you must indicate time at that maximum point. Three, you must indicate the period for the entire motion of the ball. Because I said good position versus time graph, you are answering this question, where is the ball at what time? So you must tell even someone who doesn't have science background, where is the ball at what time? They're just interested in that. Now let's draw our graph. So we're going to have something like that. So I'll have my delta y in terms of meters. I'll have my delta t in terms of seconds. We're going to analytically decide on time at the maximum point and time after the motion, after the ball has completed its motion. But they told us that answer. They said it takes 5 seconds for the ball to reach Temba's end. Right? If it takes 5 seconds, Temba just projected the ball, it takes 5 seconds for the ball to come back to Temba's end. Right? I said T1 is equal to T2. Right? Meaning the time it will take for the ball to reach the maximum point will be half of 5. What is half of 5? 2.5. So here you indicate 2.5. Here you indicate 5. Right? Very easy. Now I'm going to have that. Here you're going to indicate 30,625. Now, I'm trying my best. So, right, half of 5 is 2.5. So we're going to have 2.5, 2.5. The time for the ball to go up is equal to the time for the ball to come down. So I have 2.5 going up. I'll also have 2.5 coming down. So I have my position versus time graph. You state it there. Position versus time graph. So let's make a quick note. When you are doing this kind of graph, you need to give your graph a heading, right? You need to label the axis. So I have y, I have x there, right? Now on my y-axis I have delta y, but this delta y will be denoted in terms of meters. So that's why I didn't indicate 30,625 meters, because I've already mentioned it there. It will be denoted in terms of meters. Here I have time. I've already noted that my time is given in terms of seconds. That's why I didn't include seconds there. Good. So this 5 to be precise, it will be here. Any other questions? Let's go to velocity versus time graph. The question that we are answering here is, what is the velocity of the ball at what time? Can I have that? Yes, good. So here you must indicate the initial velocity. Here it's very important that you indicate the initial velocity. Good. Initial velocity for the upward motion and the final velocity for the downward motion. Initial velocity for the upward motion and the final velocity for the downward motion. I'm giving you a trick right now. It's mathematically proven. The initial velocity for the upward motion is the final velocity for the downward motion. You just change signs. If the initial velocity was positive, you take its magnitude. Its magnitude will be the magnitude of the final velocity for the downward motion. You just change the sign, but it will be negative. You'll see now. I'm taking upward as positive. Please write here, upward is positive. Good. What was the initial velocity?
24.
24, I have 24,5. Here I'll have velocity in terms of meters per second. Here I'll have time in terms of seconds, right? I'm saying initial velocity for the upward motion is equals to the final velocity for the downward motion. You just take it as it is here, but you change sign. I'm saying you take it as it is there, it's 24,5, but it will be negative. So I have my positive velocity here, I have my negative velocity this side. So this one will be positive, this one will be negative. Good. Now, here it will be the time it took for my projectile to reach the maximum point. What is that time? 2,5 seconds. 2,5 seconds. So here I have 2,5 seconds, here I'll have 5. Right? So I have that. Now I have that. Now, because of my graph, I want to be my negative 24,5 supposed to be there. Do you guys understand? Again, if I have T1 here and I have T2 here, T1 is equals to T2. Upward is positive. Upward is positive. Do you see that? Meaning initial velocity, Timber threw the ball vertically upward. Timber threw the ball vertically upward. When he threw the ball vertically upward, this denotes his motion when he was going upward and the ball reached this point, positive. But the minute when the ball was going down, the velocity became negative, but it was increasing negative. It started as 0 there, it ended up as 24,5. But because it was going down, we're going to have negative 24,5. Any other questions?
Yes.
Good. Now, remember to name your graph there. You're going to have velocity versus time. Always, you name your graph there. Now, let's go to the last one. Acceleration versus time graph. Are there any other questions here? Are there any other questions here? Have you answered the question? Remember we said for someone, you need to be able to tell that particular someone what is the velocity at what time. You told this person that the velocity at time 0 is 24,5 meters per second. We told this particular person that velocity at time 2,5 seconds is 0 meters per second. And you've also answered this particular person that the velocity at time 5 seconds is equals to negative 24,5 seconds. So we have answered the question, what is the velocity at what time? I'm interested in that. Now let's go to acceleration. The easiest one. So I have that, I'll have t in terms of seconds, I'll have acceleration here in terms of meters per second. I said upward is positive, upward is positive, upward is positive, upward is positive. If upward is positive, the force of gravity is acting in which way?
Upward.
The force of gravity is acting?
Downwards.
Downwards. Right? The force of gravity is acting downward. Meaning that acceleration is a vector. Right? Its direction is downward. How do we denote downward in terms of negative and positive? Downward will be denoted by negative. Do you guys understand? So if I have something here, I'm going to have my acceleration here. Because you state here upward is positive. Let me retort this. So you can have something like that. You just need to denote that if you have something like that, upward is positive. Acceleration is acting downwards, right? So I'll have my g here, but it's constant. So we'll have 9,8, right? But it's negative because it's acting downwards. Upward is positive. But you only draw this kind of graph if you say upward positive. If upward was negative, then anything that was going to go down was going to be positive. Questions? Good. We are going to deal with equations of motions. After that, we are going to do the consolidated exercises. Then we conclude.